Hello and welcome back to the Change Dude podcast. I'm your host Saeed, and today we are untangling 4 acronyms you will see in every architecture meeting, blog post, and demo about Agentic AI. First is RAG or Retrieval-Augmented Generation. Second, the Model Context Protocol or MCP. Third, Agent-to-Agent or A2A communication. And Subagents. My goal for this episode is practically give you a clean explainer for each, show short real-world examples where each shines, and then compare them so you can pick the right tool for the right job. This is not a paper review episode, it's a build or choose episode. It will also call out current limitations and what each pattern reveals about safe, scalable agentic AI. I drew on a mix of developer docs, engineering write-ups, and recent industry pieces while putting this together. So let's get into it. As LLMs become good at language, builders discovered that the hard part of making them useful in production isn't fluency, it is connecting them to reality, such as your private data, your steps of work, and other systems. The 4 approaches we will cover are ways to give models real context and real power, but each has a different trade-off. RAG is about knowledge retrieval. MCP is about a standardized bridge to tool and data. A2A or agent-to-agent communication is about agents talking to and delegating to each other. And sub-agents are an internal orchestration pattern inside a multi-agent flow. Knowing which to use is like picking the right kitchen tool. A chef wouldn't use a blender to sharpen a knife. Over the next few minutes, you will get a usable mental model and a few crisp examples you can try. So let's start with RAG. RAG stands for Retrieval-Augmented Generation. At its simplest, RAG systems takes a user query, search an indexed knowledge base for relevant documents or passages, and then give those retrieved chunks to the language model as context for generation. The idea is to let the model answer from up-to-date, verifiable sources that aren't baked into the model's training snapshot. Practically, this looks like embed your documents, index them in a vector store, run a similarity search when a query comes in, and then include the top matches as part of the prompt that the LLM consumes before producing its answer. This reduces hallucination and lets a single assistant surface internal policies, manuals, or product documents on demand. Imagine you work in customer support of an airline and a user asks about baggage rules for a special fare purchased yesterday. A RAG pipeline searches the company's policy docs, the fare rules, returns the exact paragraph that describes baggage allowance for that fare, and the model replies quoting the policy and adding a short plain language summary. In short, RAG is best when accurate facts drawn from a corpus are the primary need. Updatable knowledge, compliance rules, long manuals, or anything you want the model to ground the information on. But RAG has limitations. It depends on the quality and freshness of the index documents, and retrieval can surface outdated or contradictory copies, a problem sometimes called version drift. RAG also requires careful design of prompts and retrieval to rank pipelines. You must decide how much context to pass, how to stitch multiple documents together, and how to present provenance to users. Lastly, RAG doesn't inherently give the model the ability to act, it provides context and not the execution. Now let's talk about MCP or the Model Context Protocol. That is an open standard that defines how models and apps discover and use external tools, services, and data sources. Think of MCP as a universal connector or USB-C for AI. It standardizes the way an LLM can list, request, and be granted access to external capabilities without each integration being custom built. MCP provides a registry and a schema for capabilities such as files, databases, calculators, web searches, specialized business operations, so that an agent can dynamically discover what it can use, ask for permission, and then call those tools as part of a workflow. The MCP project describes itself as a standard to connect models to external systems they need to do real work. A simple MCP example: imagine a virtual assistant that can both answer questions and act on your calendar. The assistant queries the MCP registry, discovers a calendar service, asks the platform for permission to view a specific calendar, and then calls a create event tool exposed by the calendar service. Because the interface is standardized, the same assistant code can work across different calendar providers that register with MCP. MCP therefore elevates agents from read-only assistants into actors who can both read context and execute actions in systems securely. Microsoft's efforts to bake MCP into platforms like Windows show how MCP can be embedded at OS and application boundaries to enable richer, natural language-driven interactions with apps. MCP's downsides are mostly about security and governance. Exposing an LLM to tools and data means you must solve authentication, least privilege, token leakage, and prompt injection at the protocol and platform layers. Standardization helps, but it also raises the stakes. A misconfigured MCP tool can become an attack surface for agent breaches. So, MCP requires solid operational controls, vetting of MCP tool providers, and careful runtime isolation. Now let's talk about A2A, or agent to agent. It is a protocol and an architectural idea for letting autonomous agents communicate, coordinate, and delegate tasks to each other safely and interoperably. Where MCP standardizes how one agent discovers and uses tools, A2A standardizes how agents discover each other, exchange capabilities, and form collaborative workflows. When building ecosystems of agents, a billing agent, a procurement agent, a scheduling agent, A2A is the glue that helps them negotiate work and hand off responsibilities. Google's developer blog and A2A descriptions frame it as a secure, vendor-neutral protocol for cross-agent collaboration that can work across enterprise boundaries. A practical A2A example: suppose an agent representing sales receives a request to provision a promotional trial for a key account. It might use A2A to query a billing agent to confirm account standing, then ask a provisioning agent to allocate trial resources, then call the legal agent to check contract constraints. Each agent specialized, each exposing capabilities to A2A. The lead agent orchestrates the flow, but the heavy lifting is delegated to specialized agents speaking the same A2A language. This pattern is powerful when tasks naturally split into roles by domain and when different teams or vendors own separate agents. A2A challenges include latency, trust, and emergent behavior. When you let many autonomous agents negotiate and act, you need robust identity, authorization, audit trails, and mechanisms to prevent runaway delegation chains. Observability, knowing which agent did what and why, becomes essential to safety and compliance. Now, last but not the least, subagents. Subagents are an internal orchestration pattern where a lead agent spawns smaller, focused subagents to explore different parts of a problem in parallel or sequence, then aggregates their results. This is not necessarily a protocol like MCP or A2A, it's a design for decomposition. Subagents are usually lightweight. One subagent might be tasked only with web search, another with structured data lookup, another with hypothesis testing, and the lead agent synthesizes and verifies their outputs. Anthropic and several multi-agent engineering teams describe subagents as a practical way to scale complex reasoning by turning big tasks into many small, specialized ones. For example, a research assistant agent answering, "What are the top 10 startups in climate tech fundraising this quarter?" could spawn subagents. One scans news feeds, one queries Crunchbase or a private dataset, one validates funding amounts and dates, and one writes an executive summary. The lead agent reconciles conflicts, checks provenance, and returns a consolidated answer. Subagents keep the system modular and make it easier to retry, cache, and observe small parts of the pipeline rather than a single monolithic run. However, subagents increase orchestration complexity, and the more you spawn, the more risk you have of inconsistent assumptions, race conditions, and compounded hallucinations unless you build checks and consensus rules. Subagents are best for complex, multifaceted tasks where parallel specialization is a clear win. Now let's talk about when to pick RAG, MCP, A2A, or subagents, and we are going to talk about some practical rules of thumb. If your primary need is accurate, up-to-date answers drawn from documents you control, start with RAG. It's the fastest way to ground an LLM on existing text assets and reduce hallucination. If the user's intent is "tell me what our policy says" or "summarize this manual," RAG is the right tool. If you want models to act, create calendar events, run a payment, or read a private database, adopt MCP patterns. MCP gives you a standardized, auditable route for agents to request and use capabilities across systems, which is essential for production action flows. Now, if your problem naturally decomposes into multiple domain specialists, or you need agents owned by different teams or vendors to collaborate, A2A is the right architectural idea. Use A2A when responsibility crosses organizational boundaries and you want secure, discoverable agent interactions. If your task is complex and benefits from deliberate decomposition, parallel data gathering, independent checks, or specialized microskills, use subagents under a lead agent. Subagents are about internal scale and modularity, not about exposing new external capabilities. Then it's important to stress these are not mutually exclusive. RAG can be a subcomponent of an MCP tool. An MCP-enabled agent can use RAG to answer questions, and A2A to ask a neighboring agent for a domain-specific approval. Subagents can be spawned by a lead agent that itself uses MCP to call tools. The practical skill is composability and knowing which layer solves which problem. I would like to now cover two short practical scenarios to compare choices. The first scenario is a customer asks, "Is feature X covered under our enterprise SLA? And can you schedule a remediation call if it is not?" If you only need to surface the SLA clause, a RAG pipeline against contract docs answers the first part quickly. If the user asks to schedule the call, you need the agent to act on calendars and possibly authenticate to calendar APIs. That's where MCP becomes useful. If scheduling needs approval from another team, an A2A call to a team-owned approval agent can handle it. If the overall workflow is complex, check contracts, check on-call roster, find available times, and validate compliance. Breaking tasks into subagents makes the flow robust and parallelizable. This shows how RAG goes to MCP, which goes to A2A, which goes to subagents, can chain in one user story. The second scenario is a brand monitoring system needs to find emerging misinformation across social channels and prepare a short remediation plan. For fast discovery, spawn subagents that watch Twitter, Reddit, and news APIs. Use RAG to ground flag claims against trusted sources and internal policy. If remediation needs an action, issuing a takedown or sending a PR draft to legal, The agent needs MCP-style access to tooling or A2A to call the legal agent. Here, the combination of sub-agent plus RAG plus MCP or A2A is again practical. Right now, RAG is a well-understood production-ready approach used by many enterprise apps to put updatable knowledge in front of LLMs. There are mature vector stores, libraries, and many patterns for chunking, filtering, and provenance. MCP is quickly gaining adoption as a standard for tool integrations and has been integrated experimentally into platforms. It's moving from proof of concept into platform support. A2A is newer but is already being promoted by major players as the protocol for multi-agent collaboration, particularly for enterprise scenarios where agents from different vendors must interoperate. Sub-agent orchestration is a practical engineering pattern many teams use when they need modular, observable, and retriable multi-step reasoning. These approaches are being piloted across clouds and OS platforms, and you can run meaningful proof of concept today. But don't confuse demos with solved problems. The current state of art handles many structured, well-scoped tasks well. It struggles when the domain requires deep compositional reasoning across ambiguous human goals or when governance is immature. Safety, auditability, identity, and governance remain the trickiest operational problems as agents gain the ability to act autonomously. So here we are with the key limitations to watch for. There are 4 practical risks that often get underplayed. First is data leakage. When agents call tools or other agents, secrets and tokens must be guarded. Second is authorization creep. Once an agent can act, what policies prevent it from doing too much? Third is provenance and version drift. RAG systems can confidently return outdated documents if your indexing or metadata isn't rigorous. Fourth is emergent delegation. When many agents interact via A2A, they can create long chains of delegated actions that are hard to stop, audit, or reverse. Addressing these requires engineering, telemetry, policy engines, least privilege, and human-in-the-loop gates for high-risk actions. Before choosing a pattern for a new feature, ask 4 quick implementable questions. Do you need fresh authoritative text? If yes, start with RAG. Do you need action inside other systems? If yes, design an MCP or tool integration with strict auth. Do you need cross-team or cross-vendor collaboration? If yes, prefer an A2A approach for discoverability and delegation. Do you have a complex multi-step task that benefits from parallel specialization? If yes, design sub-agents with a lead agent and clear contracts between them. These questions map directly to the choices we covered. Over the next 12 to 36 months, expect more standardization and platform support. Protocols like MCP and A2A will be incorporated into operating systems and cloud tooling to make secure discovery and execution easier. We will see richer registries of vetted MCP tools, better identity solutions for agents, stronger telemetry to detect agent breaches. On the capabilities side, agents will get better at long-running workflows, fault recovery, and cross-agent negotiation. Architectures that combine RAG, MCP, A2A, and sub-agents will become a standard toolkit for building reliable, auditable agentic systems rather than boutique research projects. At the same time, regulatory and governance frameworks will force more conservative defaults in industries like finance and healthcare. If you are building now, start with what you can secure and measure. Deploy RAG for a read-only feature and instrument provenance. Add MCP-style tool gating for any action features and test A2A only after you have identity and audit. For complex tasks, prototype sub-agents locally before you ever expose them to production traffic. And always test failure modes. What happens if a tool is compromised or a sub-agent returns garbage? Build the human override first. So to quickly summarize all of this again, RAG, MCP, A2A, and Subagents are four powerful complementary approaches. RAG grounds language with facts, MCP standardizes action and capability access, A2A opens agent ecosystems for collaboration, and Subagents let you scale reasoning by specialization. Use RAG when you need accurate facts, use MCP when you need safe acts, use A2A when you need cross-agent negotiation, and use subagents when tasks need modular parallel work. Above all, design with security, observability, and human control in the loop. Thank you for listening to the Change Dude podcast. If you found this episode useful, share it with a friend who is building an agentic future, and tell me which architecture you are wrestling with. I'll be back next time with another interesting topic. Until next time.